All right, so let's go back. Okay, so I'm going to look at the application of this application of whatever you learn. Okay, especially the speckle triangle. In this case, so first thing is you remember that our Earth is a lot more like a sphere. So that's why we have speckle triangle here. Okay, what is a speckle triangle? Actually, you have a triangle that pass through contain the center of the Earth, so they call great circle. So a speckle triangle consists of great circle. Three sides of great circle form a triangle. Okay, so this is how the speckle triangle come about. In application, when a ship say move from point A to point B, so then how do we calculate the distance between point A and point B? Okay, and usually the way to calculate the distance, you have to introduce a North Pole. Okay,
So I've got a question.
yes,
This triangle, right? It's not right angle triangle, also, right?
no, general triangle. Okay, not necessarily right angle. Most of the time they are not right angle. Okay, most of the time they are general triangle. So you have a North Pole, right? Somewhere called P here, and then you try to measure distance from A to B, right? So when you travel the North Pole, you see what happens is normally when they do the drawing, we always say this is North Pole, this is north side, right? The ship go in this way, ship direction of ship, right? So usually it's an angle here, alpha. Okay, alpha usually is called the bearing. Okay, it's a measure from the North Pole. Okay, so where is the North Pole now? So in this case, you usually draw a straight line, right? But on a sphere, it is not a straight line anymore. It's just pointing towards the North Pole. So this is pointing towards North Pole now. Pointing towards North Pole. Okay. Then the direction of the ship is called bearing, right? Alpha, and this is the bearing here. Okay. Alpha is the bearing here. So bearing here is the alpha direction the ship moving. Measure from the North Pole, right? So actually the North Pole, you go down, you get the alpha, and this is where is alpha look like. Same thing here. As the ship move along this direction, you see the arrow move here. Okay. So what is the bearing now after you move to B already? So after you move to B already, you can now have bearing now. So this and this is at alpha at A, this at B now. Then the bearing change, all right? Because it move. So you move here is beta now. Measure from the North Pole. Okay. So bearing on the ship, change direction already. So this is the beta now. The beta here, which is here now. Okay, we have a name for this, right? Alpha is called the initial cost of the ship. So alpha is called the initial cost. So basically initial direction of the ship. And beta is called the final cost. Okay, final cost of ship. So this is how the initial cost and final cost of the ship there. And the distance between A and B, okay, we just the distance between A and B lah, but because this is a distance measure in degree now, okay, distance measure in degree, then you'll find distance between A and B. So this is a rough picture of how this alpha and beta come from. Okay, this actually the way you draw the bearing North Pole. and then from here you find the bearing from this here. So the picture, this one is a more complete picture here. Okay, something more. No weapon. Okay, so this show you the talk about initial cost and final cost. Okay, so it's a spherical triangle. So let me continue the explanation of using this picture here. Okay, this picture here. So I'm going to talk about what is the co-latitude of A. Okay, co-latitude of A, there's something called the co-latitude of A. This is the distance between A to the North Pole. Okay, distance between the A to the North Pole. So this is actually the co-latitude of A is actually distance between the A to the North Pole here. Okay, A to the North, distance between A to the North Pole. That's co-latitude. Okay, and then of course the distance between B and the North Pole is actually co-latitude of B. It is the part mentioned here. Co-latitude of A, co-latitude of B. Now, distance between A and B is called a great circle distance. Okay, we just side AB here. So this is a great circle distance here. So you can inform that it's a spherical triangle here. I mentioned already the initial cost. Alpha is initial cost. Beta is the final cost. All right. So initial cost, I mentioned this earlier. Initial cost measured from the North Pole. Okay, this is actually toward North Pole. So we get this bearing of A is initial cost at a ship from A, and bearing of the ship from B when it move away is the final cost. Okay, then the next thing I want to mention is called the vertex. You see the word highlighted vertex here, the vertex. Okay, so the vertex somewhere here. Okay, vertex is what? Vertex is a point along the A to B, along the point A to B, where it is nearest to the North Pole. In this case, sometimes it could be nearest to the South Pole, okay, depending on the path. But this time, for this picture, it's the nearest point to the North Pole along the great circle A to B. So somewhere here, there's a vertex here, You can call this V here. So this is V here, vertex. Okay, vertex here. Okay, it's nearest to the North Pole. So for North Pole, you must get the nearest point. Okay, the meaning of nearest point means angle must be 90 degrees. Okay, angle must 90 degrees. So basically, the vertex is the nearest point to the North Pole in this case. Because of this, it must join the North Pole and cut the circle AB at 90 degrees. Okay, so this is the vertex. Okay, and then what else? Okay, so this usually for this first example we are going to find the vertex when a sheet move from one point to another point. Okay, so now let's move on to example. So we will skip example 7 and 8. We can ignore them. Okay, 7 and 8 you can ignore them. Okay, we are not going to test you this for called the 4-part theorem. So we start from example 9, where real application. Okay. So example 9, let's see what happened now. Okay, the question, the sheet leave a position 25 degree 31 minute north 60° west, and follow a great circle track. Okay, so the ship, I think, let's draw here first. So you have a point A here. I think, do you see how it moves? Okay, I think it's moving upwards. Okay, okay, it's going upward because the bearing. Okay, so basically, you have a ship here, A. Okay, the location of A is 25 degree 31 minutes north and 60 degree west. So instead of drawing a North Pole particularly, I'm going to say this P here is North Pole here, and it's how the direction it moves, right? So when you draw North Pole there, so North Pole here. So bearing is 68 degree, right? So this bearing tell you 60 initial ship it move in this bearing 68 degree. It's an initial course. So this thing actually, if you draw like this, you know that this is direction to the North Pole. Okay, direction to North Pole. And so this angle tell you that this is 68 degree. Okay, so actually ship move in this way. So from here you can see that the ship is moving east toward east and moving towards north, because when you draw the picture of this, okay, this A here, North Pole here, this is actually the direction 68 degree. Okay, the ship is actually moved toward east and north. Okay, basically you can see that the ship is moving towards east and north. Okay, the ship here. Okay, so you know that it's going to go toward east side and north side because of the direction. Okay, then what else you need to know? Find the latitude and longitude of the north vertex on the track. So what does it mean? That just I mentioned about north vertex now. Okay, what the direction, latitude or longitude of the north vertex on the track. So if you move this way, vertex basically is the nearest point, in this case to the North Pole. So if you want to draw all the vertex, so this one, the direction of the ship here, somewhere here there's a vertex here, V. Why is it vertex now? The meaning of vertex means that this is 90 degrees, nearest point to the North Pole. Okay, North Pole. So the triangle looks something like this. Okay, so we have to find out the latitude here, and the longitude, right? So this is what we need to find, location of the vortex. Okay, so how to go about this? Okay, so I'll try to show you the talking. Usually you have to find what you know, right? So guys, if I given this information early, let's try to figure out a few things. One of them, can you find the co-latitude of A first? That's the first part. Okay, co-latitude of A basically is the distance PA. Okay, the distance PA is the co-latitude of A. So let's find out here. Okay, so this distance here, PA. Okay, This is this one could be a. So PA is called the co-latitude of A. PA, okay, distance PA is at the co-latitude, okay, co-latitude of A. What is this PA now? So the way to understand this is to draw the sphere for you. Okay, I don't draw a sphere for you. Right? So this is Earth here. This Earth here. Okay, then okay, so this Earth here, and then this center of the Earth, and this is the equator. Okay, this is the equator here. Okay, what is latitude of A? Latitude A is somewhere here. Let's say this is the meridian here. I don't know west. This is actually the 60° west. Okay, this line, 60° west. And then this one is the point A here. The point A is here. Okay. What is this long latitude of A? Okay, from the question, the longitude of A is 25 degree 31 minute north. That means that this angle here is 25 degree 31 minutes. Okay, this is how you know the latitude is measured from the equator. Okay, latitude measured from equator, and this is North Pole. North Pole is on top here. So the line is a meridian 60° north, 60° west here. So this line is actually 60° west. Okay. And then what is the distance from P? P is North Pole here. So you know the center of the Earth to North Pole, the total angle should be 90 degree, right? This is 0 degree because equator means 0 degree north. Okay, equator means 0 degree north, and North Pole means 90 degree north. So the angle between the equator and North Pole is 90 degree. So PA, which we're looking for now, is this distance here. So what is the distance measured in degree now? So this co-latitude here, co-latitude here, co-latitude of A is just 90 degree minus 25 degree 31 minutes. It's co-latitude of A, right? So this distance I highlight to you is actually 64 degree 29 minutes. Okay, the distance measured in degree, that means that this angle here is 64 degree 29 minutes, and this is the co-latitude of A. Measuring all the measurement is measured in degree minute now. Okay, this is how you understand the distance between 2 points on the Earth. Okay, you just use the angle measure. Okay, so this is called co-latitude here. So I go back here. Co-latitude of A is just 90 minus 25 degree 31 minute. You get 64 degree 29 minute. That's PA, right? So this distance PA is 64 degree 29 minutes. And you know angle A now, and happen that you have a right angle triangle. Okay, yeah, right angle triangle, and then vertex at V, right? So okay, vertex at V, which is 90 degree, And the initial cos A alpha equal to 68 degree initial cos, true bearing. Okay, this is actually true bearing here, which alpha equal to 68 degree now. Cool, because this is a right angle spherical triangle. Immediately, what comes to you to solve this problem? Of course, is the Napier's rule. Okay, immediately you want to solve the triangle, you must turn to Napier's rule. Okay, so let me redraw this triangle here and then copy this. I don't need to draw. Then copy this in and use the not good. Right. Okay, use the select first. Okay, I'll show you the picture here. So I did copy here. So I'm going to go to the next page here. Okay, I insert more page here. Now I paste it. Yeah, I come like that. Good. Anyway, let me erase all this thing. Okay, so let's try to understand this situation. Okay, now you can apply the Napier's rule now. So Napier's rule, you must draw a Napier's wheel, right? So how do you draw the Napier's wheel? You have to understand how the Napier's wheel will work. So you will see how it go into the vertex first. Okay, this is going to vertex this direction. Going to vertex, leaving the vertex clockwise, then meet the angle A, and then move to the North Pole. Okay, so if you want to draw the Napier's wheel, okay, this Napier's wheel will look something like this. So consists of the Napier's wheel will consist of 5 parts. Okay, the Napier's wheel will consist of 5 parts. Upper half, 2 parts. Lower half, 3 parts. With a comb. And the center is the vertex V, which is 90 degree. Okay, then you start filling it now when you go into the vertex. The when you go in the vertex is actually side PV. Okay, so go from the side PV here. Okay, PV. Then get out of, you get VA. So get a VA. Then meet the angle A. Then go to side PA or AP. Then so AP here, AP now. Then finally meet at the angle P. Okay, then you fill in the information or the information you have. Okay, I know PA. PA is the same as AP, right? So this is 64 degree, 29 minutes. And I know angle A. Angle A is here, 68 degree. Okay, so Now you ask yourself, out of so many things you can find, which one you should find first? Right? Out of so many things you can find, which one you can find first? So now apply the Napier's rule. Napier's rule has very common as a very simple rule. This one is the first thing, PV, because this is the only thing you know, because you can use this opposite of PV to find. Okay, you can use this opposite of PV to find. So this is a simplest, the first reaction. Okay, you are given what? These are two answers in blue one. What's the next easiest information you can find is a PV. And this is how you think about how you solve the problem, so that you are not getting too complicated, or what is the thing supposed to do next, right? Just what I'm trying to do so that you don't need to think too hard. Just put them in the correct sequence. Okay, the sequence always like a logical sequence. So in the Napier's rule, what does Napier's rule say? Napier's rule say that sine of middle part, this is one of them, is product of cosine of opposite. Okay, this is one of the Napier's rule. Sine of middle part usually use a yellow color, and product of the opposite I usually use a blue color. Yeah. So product of cosine opposite. So now I can write down the formula I want to find. So sine of middle part now. So sine of middle part is PV. We want to find PV, right? It's the product of cosine, so it's cosine. Now the problem is opposite the A and PA. Both are in the lower view. So this is product of column A now. Column A. Because why you column A? Because A is in the lower half of the view. Times cosine of column AP. Okay, you need to do column because both are in the lower half of the view. PV is upper half, so don't need to do column. So this will give you now cosine of column A. Okay, column A means 90 degree minus A. Okay, column A means 90 degree minus A. But you can simplify cosine of column A, straight away, you know, this is sine A. Okay, cosine of column A is equal to sine A straight away. Cosine of column AP equal to sine AP straight away. Okay, so now you put in the calculator, what is actually, okay, this is put in there. This is actually sine. A is 68 degree. And then sine AP is 64 degree. 29 minutes. Press the calculator. 0.8 367. Yeah, a long string of number. Usually for this, you press the calculator, then you can find out what is PV now. So PV is equal to sine inverse of this number. Not exactly this number, but you also calculator, you get a long string number, so I don't bother to write down. I just take this number and then you press sine inverse. Then you get the answer 56 degree 48 millimeter. Okay, you don't get 0.8367, but it's a long string. You continue to write there. Okay, 4635. Okay, 461355. Okay, something like that. Okay, so press sine inverse now. You get 56 degree 48 minutes is the length of PV. Okay, what is another length? Because you put sine inverse, right? Or you can say, or PV is this one, because 180 degree minus 56 degree 48 minutes. Okay, then you can press the calculator, you get the answer. Okay, 180 minus 56 degree 48 minutes. Of course, this is not necessary, because if once you know the answer already, it's actually not necessary to do this. I just tell you the answer, another possibility. Okay, because obviously the answer is 56 degree 48 minutes, right? Why is it so? Why is it we reject this one? In case you wonder. Okay, why is it we reject this one? Because the largest angle in the triangle is 90 degree. Okay, largest angle in this triangle is 90 degree. So 90 degree is corresponding to what? The size 90 degree is here, corresponding to 6429. That means that 64 degree 29 is the largest side already. This is the longer side only. Okay, this is the longer side. Because the angle 90 degrees is largest angle. And this is longer side. Therefore, PV must be less than 64 degree 29 minutes, right? As PV must be less than 64 degree 29 minutes. That's why people reject this one without even consider the other angle, because it's too large already. So people don't bother to calculate this one because cannot be that big, right? Because PV cannot be that long. So we reject this. So very often people will ignore this calculation because by the nature of problem, you know that you don't need to do this. Okay, usually ignore. In real application, usually ignore in real application. And in normal triangle, you have to calculate. Just now last time we do normal triangle, you have to calculate. But real application, you don't need, because the only angle that makes sense from here is this one now. Okay, that's why you don't need. So this answers the first part already. I know PV now. So PV is equal to what now? 56 degree 48 minute PV. Okay, so this PV here is 56 degree 48 minute now. So yeah, no more information already. So I can WhatsApp this to you. Let's see. WhatsApp this to you first. Okay, I know this is 21222 now. Okay, I can WhatsApp this to you. It's a sample 9. How to get this one? So example 9, let me go to the earlier one. So this is the picture explanation. Okay, so example 9, let me WhatsApp this to you. Okay, up to here now. So beginning problem. Then I draw the great circle. Okay, explain to you how to calculate distance. And then how to apply Napier's view. Okay, Napier's view is actually this one, right? Okay, Napier's view. At least at the moment now, we haven't Napier's view. Okay, now I want to continue. Copy this page and find the next thing, right? So let me copy this thing. So copy page first, and then edit, copy page. Then go to next page here and paste it here. Okay, now I'm going to move on to find the next thing. Okay, so I did erase all the working, erase this now because I want to use another Napier's rule now. Okay, I want to erase another Napier's rule now. So let me erase the color now. So the color is not this one I want anymore. So based on what is given now, okay, based on what is given, what is the next thing you can try? Okay, you can try to find VA because you get two adjacent there. You can try to find P. Okay, so you can try to find P also because of this. So let me try to find P first. So I want to find the middle. Middle always is yellow color. And then there are two adjacent there. Okay, because I can do this. Two adjacent. Okay, make use of that. So in the Napier's rule, now I can say the Napier's rule, what is the formula? Always sine of the middle part is equal to product of tangent of adjacent. Yeah, two adjacent there. So sine of middle part is the orange, yellow one. The product of adjacent. Adjacent, I use green color. So that means that, okay, what is this now? Middle part is P now. So sine of P, but P is in the lower half, so it's com P. Okay, sine of com P, because P is on the lower half. And product of tangent, okay? So tangent of PV here, PV upper half. So tangent of PV, then times tangent of com AP. Because AP is low half there. Okay, so you notice that this is product tangent now, and then this is a com there. So sine comma P, we know that sine comma P, you can simplify it so that you don't need to work so hard with so many minus sign. Okay, so this sine comma P actually same as cosine of P. Now tangent PV times, Now tangent comma AP, so this is something you must remember. Tangent comma AP is actually 1 over tangent AP. Okay, tangent PV is actually tangent of 56 degree 48 minutes, and then the tangent of AP, which is 64 degree 29 minutes. So you can try to find P now. So then you have to calculate this one. Okay, say why this thing. So cosine P is equal to what now? So let's calculate the tangent of 56 degree 48 minute. Okay, and then divided by tangent of 64 degree 29 minutes, and then you see what I get, 0.729. Okay, so you got P here, cosine inverse of 0.7294, and so you take cosine inverse of this, so shift cosine inverse, the answer get 41 degree 8 minutes 10 minutes. Okay, 41 43 degree 10 minutes. Good. So angle P is 43 degree 10 minutes. Okay, so this is important information. Let me WhatsApp to you. Afterward, then you see how to interpret this. What is so important about P is tell you where's the location of V now. Where's the location of V? Okay, what's so important about P here is telling you how the location of V look like. So I go back to the sphere we draw earlier. This is a sphere, right? So the point, the shape A go to I don't know where it go to, but this time it go to V, right? So how it go to V? You look at the direction I draw. How to go to V? Okay, this one. Okay, from the direction you draw, you can show that this shape actually move to V. How to move to V? You go toward east. Okay, mean direction eastward. You go to eastward and northward. Right? You actually go to the east side and north side. Okay, go to east north direction. Okay, so how do you find the angle V? So, okay, so if you draw the sphere again, okay, go sphere again. Let's see where is it now. Okay, so notice that this is how I'm going to draw now. It's going toward east, north. Okay, the direction is 68 degree. Bearing. So this is the V. This angle is a P now. Okay, This angle is a P. So I draw it bigger so that you can see clearer. So this angle is a P now. So let me blow up this diagram. Okay, blow up this diagram, larger it. Okay, the angle P. So we find that angle P is 43 degree, 10 minutes. Okay, so and this line is 60 degree west. Okay, this line is 60 degree west at the point A. And because of this angle 43 degree, 10 minutes, where is the latitude, no, sorry, longitude of V now? So location of V, right? So first of all, the longitude of V. So you move to the east side, right? So the longitude of V. Okay, the longitude of V is, you have to subtract this, right? Find the longitude of V is actually 90 degree, no, it's 60 degree first. It's on the west side, 60 degree west, right? You move, because you move to the east side, you subtract 43 degree, 10 minutes. Okay, so that you get now, this is still in the west side. After, because actually you done, that's not overshoot, right? Still in the west side. This is actually 16 degree, 50 minutes west. So this line here, is 16 degree, 50 minutes west. 16 degree, 50 minutes west. Okay, 15 minutes, 16 degrees west, right? So this line here, so this is how the things are connected, because P is 43 degree, 10 minutes. We go towards the east side, right? So we go towards the east side to get V, and then you get the location now in some sense. Okay, location now. Of V. Okay, so this is how at least you know the longitude of V now. Okay, finally, I go back to this one. So I know P is 43 degree, 10 minutes. Okay, next last thing to find is a VA. The VA, so last thing to find is a VA. Do you need, no, there's a, they don't need to find VA, right? They want to find, okay, PV. Okay, where is the latitude? Okay, because I don't need to find PA, yeah, because I find out that finally that I don't need to find this one. I just want to find that the one thing the PV. Okay, what does PV tell you? Because just now I forgot to find PV. All right, PV. Okay, PV is 56 degree 45 minutes. Okay, so that means that if I want to find the latitude of V, now I'll go back to the great circle distance. Okay, just now I forgot to find PV. So PVR. So I don't need this one. I can go back to find this PV now. PV I have this one 50 okay, then I can talk about longitude, latitude of V now. Okay, 56 degree, 48 minutes is the length of PV. So go back to the sphere I have just now. Okay, this distance PV if 56 degree and 48 minutes. Basically, then where's the latitude of V now? So go from the center of the Earth, equator. Okay, this angle is how much? So the latitude of V is just take 90 degree minus 56 degree, 48 minutes, and then you will get 33 degree, 12 minutes. No. So that means that this distance, the location of V, this one is 33 degree, 12 minutes. This is the latitude. So the latitude is 33 degree, 12 minutes, and the longitude is actually 16 degree, 50 minutes west. Right? So this is how you find the location of the vertex V. Okay, draw a picture again so that you can see this picture. In this picture, we draw again. Okay, so that's how you answer the last part, which I forgot to do just halfway only. Then, okay, the latitude of V in this case is 90 degree minus 56 degree, 48 minutes is equal to 33 degree, 12 minutes. No. Okay, so this is an example I intend to do because I don't think I have time to do an example really. So let's see how people are here today. Okay, I think a lot of people missing, no? Suppose there are 20 altogether. A lot of people missing that. That's why I recorded the lesson. I think stop recording now.